proof of work remained today the most robust and decentralized consensus algorithm that also is accessible.
In this video, Ankit has a very profound and interesting conversation with Maud from Alephium team.
We had the first over-collateralized stablecoin with the lending protocol launched. We got pretty big RWA tokenization, actually on the energy side of things.
You might ask, what is Alephium? Alephium is a proof of less work with smart contracts built directly on layer 1.
Alephium runs as a classic proof of work chain up until a certain hash rate, which in our case is 1 exahash. Instead of asking miners to pay that cost exclusively in computing power, they have to burn ETH upfront.
It has a slow emission schedule for miners and uses sharding as one of the core concepts for scaling. Alephium has unique tokenomics and emission schedule spread out over 80 years with no halving.
So here it's a much smoother decrease. So from a miner perspective, more predictable.
Both Ankit and Maud share their love for proof of work and innovation happening in blockchain.
People underestimate how much more innovation needs to happen and can happen in this space.
Hi, welcome to XXIM Podcast, your home of decentralization. Today I'm here with Maud. Maud is from Alephium. Alephium is a layer 1 blockchain. So welcome, Maud.
Thank you so much for having me. I'm pretty excited to be with you today.
Yeah, thank you, Maud, for taking time. And I see you're somewhere outside and it's a beautiful view. Would you like to show it to us? That is.
Yes.
Where are you?
I'm in Neuchâtel, Switzerland, which is not the place, the crypto place in Switzerland that people are familiar with. But actually, Neuchâtel, this is where the project is based, and Neuchâtel has a very active crypto community. I'm here today for an event called Paradigm that is taking place today, and so this is why you get a beautiful background instead of my a little bit less pretty office.
No, it is beautiful. It is beautiful, and I see it's sunny out there. So I'm happy that you're outside. So let me just quickly define Alephium, right? That's how you call it, right? Alephium.
So I think the way you say it is the proper English way to say it. I call it Alephium, but that's because that's the French in me that kind of comes out. So I think
Right.
your way is actually the proper way. It's just my brain can't, wrap it around.
Right.
So I have to throw a little bit of French in it.
Right. So I'll keep it to Alephium. I wouldn't change it. And also for anyone who's listening to this or watching this, Maud has to move inside from the beautiful view because we couldn't hear her properly. Just the context here. But cool. For me, Alephium is layer 1, proof of less work solution that's actually has smart contracts built in and has a high throughput. How do you define Alephium to someone who's brand new, who's never heard of Alephium?
So, yeah, I think the very short answer is that Alephium is one of the only and definitely the fastest proof of work layer 1 for smart contract that has been optimized for smart contract. The slightly longer answer, and I think we have time today for me to give you the slightly longer answer, is that Alephium was really born from a simple question: is like, how do we keep the decentralization and the security that proof of work and UTXO brought to Bitcoin, but still deliver a platform that is fast, that is intuitive, and with smart contract? Because I think, when Ethereum brought smart contract to the space, this is something that has so much potential. So it was kind of, how do we bring the best of both worlds? And Alephium is the chain that proves that it is possible. And that really delivers a little bit the Web3 experience we were all promised. So it's proof of work, of course, but it's proof of work with a little twist, really engineered for the future. Or proof of work mechanism is called proofoflesswork, and it reduces the energy consumption of the network by over 87% at large scale, while preserving the full security of traditional proof of work. We have our scalability solution uses sharding, and it allows the Alephium to scale the throughput beyond 20,000 TPS with 8-second block time, which is a performance that matches the most adopted smart chain with smart contract in the space, though most of them are proof of stake. And I think for me, this is my favorite innovation. The last one is really we have our own development environment. We have an accounting model called the Stateful UTXO model, also a custom virtual machine that brings together all of the expressiveness of the account model that was introduced by Ethereum, but also keeping the inherent safety of the UTXO model, eliminating a lot of the attack vector that we see in the space, like reentrancy, flash loan, unlimited approval exploit, and really focuses on both developer and user experience and security. So you know, it's a lot of innovation, but it is Alephium.
The way I understood was it's the best of both worlds, right? It was proof of work plus combined with smart contracts. I think that was the easy way to perhaps most people to get it when they're getting into this, right? But the question that came to me, right, like best of both worlds today, right? Because 2025 we're recording this, but when you guys were getting started, this is 2021, I believe, maybe earlier, white paper, whatever. But at that time, you know, Ethereum was still proof of work, and Ethereum had smart contracts. Ethereum was just getting started with this roadmap of layer twos, right, which would eventually scale Ethereum at that time. So, what was the real reason, I guess, which you guys saw to start Alephium, given Ethereum was about to become this high throughput chain?
Well, I mean, actually, Ethereum and the technical direction of Ethereum was a big motivation behind the initial research that the founder did that are the foundation of Alephium. Because it was actually 2018, I think, when he started writing the white paper, where ultimately the technology is what is implemented on Alephium. And at the time, Ethereum had already decided to move to proof of stake, for example. So that decision, it was acted much later, but that was something that was already there. And so for him, there was a lot of, as always in blockchain space, people have different perspective on technology. But for him, proof of work remained today the most robust and decentralized consensus algorithm that also, is accessible. Like today, you can run an Alephium node on any device. So you can access the blockchain, you can check blockchain data with an intermediary. You could, if on an iPhone with a little bit of, on a phone with a little bit of an open OS, you can run your node on your phone. Not an iPhone, because they don't have a super operating system. Not an iPhone, actually. But, and it was really important. And also, I mean, Ethereum at the time, sharding was actually already explored as a scalability solution, but doing sharding on an account-based chain comes with a lot of trade-off and complication that impact often the user experience. And so he really wanted actually it all started with, I want to show that there's a better way, because I'm sure there's a better way. And he started writing the white paper on the sharding algorithm called BlockFlow that does sharding, but on UTXO. And so it was really this. It's what I said before, is how do we build really the infrastructure that DeFi and an application needs for real adoption? How do we keep all of the foundational of decentralization and security that Bitcoin brought, but still unlock all of the potential of smart contracts? And so this is Alephium, is real decentralization, scalable and fast throughput for smart contracts, and most importantly, robust security at every level. Because again, already in 2021, EVM was the norm, and today still EVM is the norm, but from it being the most used doesn't mean it is the most user-friendly. There are still design choices that open a lot of attack vector. You have known attack vector that is really hard to protect yourself against, like reentrancy that I mentioned earlier. And the developer experience is far from intuitive. It is definitely the environment that is the most documented, but even with even with it being the most adopted, most documented, it's still extremely difficult to navigate and not intuitive for a developer, and even experienced developers can easily make mistakes that have dramatic consequences. So there was a want of really improve the experience both from a user and developer level.
I'm going to go through a lot of these very core concept behind Alephium, right? I want to break them down individually because I think they are perhaps to our community they are very new concepts. So it'll be good to simplify them. But let me just mention this part. We got actually introduced to Alephium through one of your community members. Called Alephium Whale. I think I wanted to give a shout out to him because obviously it introduced us to a new project, but also helped us learn about new concepts. So let me just get straight into it with on the technology side. How for people that are new, what is the definition or how do you define proof of less work? Because that's one of the key things behind Alephium, right?
This is one of the, I want to say, kind of three key innovation. It's maybe the easiest to explain. I feel you maybe your audience can tell me at the end out of all that we talk about. But basically, the way proof of less work works is that Alephium runs as a classic proof of work chain up until a certain hash rate, which in our case is 1 exahash. So once the network reaches that hash rate, what happens is that the cost of mining a new block, and so the security of the network, continue to increases with the hash rate as it does on classic proof of work. But instead of asking miners to pay that cost exclusively in computing power, they have to burn Alph upfront. And so, meaning that, for example, where your cost, let's just say, imagine the cost of mining a block is $10.
Yeah,
this is not that, but let's say $10 voila, which is the cost of your electricity for the computing power that you need to propose a block. In classic proof of work, the hash rate will increase. The $10 will go to 20 and continue to increase indefinitely. What happens with Alephium once we hit the 1 exahash threshold is that security budget where you at 10 on classic proof of work, and that 10 is used exclusively to pay for electricity. On Alephium, that 10 will actually be for the same level of hash rate, same level of security. That 10 will actually be, for example, 8 will be for electricity, and 2 will be because you will have burned $2 worth of Alph upfront. So the cost of mining a block remains 10, but it is composed differently. And so what happens is that once we hit the 1 exahash level, miners are increasingly asked to burn more Alph versus the computing power cost. And at very large scale, let's say at the maximum, that increases gradually, but at the maximum, this is a reduction of energy cost by 87% compared to classic proof of work. So, for example, if Alephium had the hash rate of Bitcoin today, let's say, if one day, if we're lucky, I wish this for us, the energy, or you could do the opposite. If Bitcoin was using proof of less work today, the energy consumption of Bitcoin would be 87% less than what it is today for the same hash rate. Right. So it is a significant decrease in the energy consumption.
So you burn a portion of Alph token after it passes the certain threshold. Is it just one threshold? Is it many thresholds that you have to look at? And what portion of the tokens they actually have to burn?
So it goes all the way to 7 over 8. Okay. So that's like 87%. So it goes from 0% is the percentage that they have to burn to 87% will be the maximum. Right. And it's gradual from 1 exahash.
Even goes over 1 exahash. So if it goes to 3 exahash, you burn more.
The hash rate can go.
I see.
It's indefinite. The more miners you have, it can go higher. But most likely, eventually, if it goes to past a certain level, from an incentive perspective, it might not be fine. You might not have an incentive to necessarily having the hash rate push much more. But it's basically this. And if the hash rate decreases, the portion that you have to burn is less. If you go below the 1 exahash threshold, then you're back to full proof of work. So it's dynamic.
this Alephium was the first project to create something where you actually use partial electricity and partial your tokens. Is this the Alephium's concept that came up with this proof of less work?
So proof of less work is Alephium concept, but the idea of combining coin burn with classic proof of work, this is ideas that have been explored in the Bitcoin space before.
Okay.
If you look at we have a white paper that you can access through the website about proof of less work, and it does cite some other research work that has been done about again how ideas to explore on how to make proof of work more energy efficient. So it does, takes inspiration from other research work, but I think we're definitely proof of less work exactly as it is and as it is designed, definitely only Alephium. But there had been research done in that direction already before.
If I'm the miner, right, if I'm burning portion of my tokens, is it the rewards that I'm earning, or I'm actually burning from my assets also? Like if I've earned 10,000 Alephium and today I've been asked to, burn X amount of tokens. So how does the burning mechanism kick in? Like, is it from my assets, or is it just from the rewards that I'll end up burning?
No, it is from the asset. You can see it as it is from the asset. In practice, this will be abstracted by the mining pool. But it is really important that the burn happens upfront. So basically, miners right now, when they propose a block, if the block is empty, you just have the Coinbase transaction, which is just the output of the reward going to the miner. And now you will have an input, which is the miner. So now Coinbase transaction will have both an input and an output, with the input will be ALF that will be burned, and the output will be then the reward to the miner. So it is really important that it is upfront, because this is how you keep the cost of mining a new block the same as proof of work. If it was just a matter of reducing the reward, you've effectively reduced the security because you've reduced the cost of proposing a block. So it is really important that this is upfront. In practice, this will be abstracted by the pool, meaning it's not that you will necessarily need effectively to have ALF in your wallet to start mining, because pool will abstract this for you. But let's say if you were a solo miner and you're mining on your own, yes, to propose your first block, you would need to have a small amount of ALF to be able to burn for the first. And then obviously you'll start accumulating more ALF for the reward. But honestly, past a certain scale, everyone mines through pools. The solo mining is usually not the norm past a certain size of chain, like a certain amount. But you can still do it. You'll just need to have a tiny amount of ALF to start, basically. But we're talking like less than 1 ALF right now with the current block reward. Again, we're far from proof of less work activating, but even at today's block reward, you would need less than 1 ALF.
Have you ever had any pushback from the miners themselves that, hey, why are you taking away my coins, right? Because, for example, when I was running my own miner, home miner, I know my electricity cost. I can manage my electricity costs, right? I know exactly how much I'm paying. But what I don't know is how much the coin is going to fluctuate, right? Coin could be here $10, coin could be here 30 cents or 10 cents, right? XYZ coin, not specifically mentioning Alephium here. So I know my cost, input cost, electricity cost, but what I don't know is the future price of Alephium, right? So I guess my question is, have you ever had any pushback from any miners or any feedback from them?
So 2 things. First is you don't know the cost of your electricity in the future, to be fair. Like it's a big topic in a lot of places and constantly, but so this was the design of proof of less work from the get-go. It's not something that has been implemented by anyone else, and again, that part hasn't been activated yet on Alephium, meaning that every miner that is currently on Alephium is mining knowing this is going to happen in the future. What is important, so this is it, so feels like they are okay with it. And the important things to remember is Alephium is a decentralized blockchain. So if imagine the future for XYZ reason, suddenly miners, node operator decide that proof of less work, they're not happy with it,
Yeah.
they can change it, right? So like if
Yeah, of course.
if the consensus of the network, decides that, you know, in the end, I don't know, we don't like it, or we would like it to be different. We'd like to have, instead of 87%, we want it to be 50. Those are things that can be obviously, provided you have the quorum and that and everyone agrees to the change. This is something that you can change. But so far, the opposite, and actually having this approach to proof of work with proof of less work has opened a lot of doors for Alephium. It's a bit less needed because the perception around proof of work is changing in the energy industry.
Yeah.
But at the time when we launched, mining was, you know, it was the devil.
Yeah.
But now the perception has really done a switch, and we see a lot of energy companies, and you see that mining actually emerged as one of the most efficient way to finance, not only to finance, but also to dimension and to transition to more sustainable energy infrastructure. And now it's part of the solution. So perception has changed, but that has opened a lot of doors also for Alephium to show that proof of work can be optimized when it comes to energy consumption, and gave a lot of interest to people, especially in the sustainability and energy fields, because they're like, oh, if I talk to my shareholder about mining, they would be like, no. But with this approach, actually, this is something that could be more interesting for them. So, so far, up until today, it's been a pretty positive reception, both on the miner side, but also it opened some opportunities for us.
Yeah. You know, we are a big believer in proof of works ourselves, and I think we think any solution that's making proof of work better, either by creating applications or by doing less work, I think these are innovative solutions either way.
Yeah, and I think, you know, for us, we're a strong believer in proof of work. Like really, as I think people underestimate the accessibility part of things, because they're like, yeah, but proof of stake, I can also participate because I can stake my stuff to a validator. But one aspect that people don't necessarily realize is the access to blockchain data. Running a node, which is basically first running a node, the blockchain are the node, like the node are the network. So being able to run a node, it means being able to be part actually of the network, but also to access the data directly. And running typically proof of work node are much more lightweight than proof of stake node, because for example, I think it's Solana. If you want to run a node, just a node to check blockchain data, the infrastructure you need is $100,000 server. That means that you have to rely on other people to check blockchain data for you, which you as an individual, maybe it's okay, but businesses are doing the same. Because not every businesses can pay 100,000 server, right? And so it means more and more people, you create a point of failure, not single point of failure, but you kind of centralize data access and make it really hard for people to access it on their own. And more people rely on intermediary. And it's also about resilience of the network. Imagine it's less likely to happen, but imagine for some reason the world lost electricity for 5 minutes, right? Or something, whatever. How quickly can you spin the network back up? Like how easy it is to have nodes started running, and what device do you need? Is like on a proof of work chain, most of them have pretty lightweight node. Again, you can run it on a phone. So that means that in case of anything happen, your network is a lot more resilient. So yeah, we're, as you can tell, proof of work believer right here.
Yeah, no, I couldn't agree more. I think we, as I said, we definitely big believers in proof of work from the day one when first time we read the white paper, Bitcoin white paper, and since then I don't think even though we can all agree that Ethereum has done good for the world, for the blockchain space on the
100%.
EVM side. They've really pushed the boundary forward on all the smart contract type of application that can be done. But I think on the decentralization bit, I think they're lost, for at least me, and for many, many people that are like us. So on that note, why don't we segue into the best of both worlds? So we talked about proof of work, proof of less work. Why don't we talk about smart contract side?
Yeah. So there's different things. I think what was important for Alephium was to build on proof of work, but also the UTXO model, which again is on so maybe just a step back. The UTXO model, that means it's very high level, right? But just so that people have this in mind with what I say after. UTXO basically means that the data that is on chain is transaction. So the data that if you look at the chain through a node, that you see is basically transaction. And from those transactions, you can reconstitute, for example, a wallet, an address with a specific balance by adding up all the transaction linked to this address. On the account model, you have a structure. The data that is on chain is account and balances, kind of like a classic database that people are used to, where you have account balances, and then you can deduce the transaction from seeing the change in balance.
Yeah.
And so the UTXO model is actually, it's doing sharding on the UTXO model is a lot more efficient. We can talk about this a little bit better when we dive into that topic. But the problem of the UTXO model is that you've seen it already when I gave my example. It's a little bit harder to build on because the data you start is very low level. So you have to kind of build abstraction on top.
Sure.
And in its original form, it's not programmable. You can't program. Whereas the account model, first, it's very close to the data structure that people are used to in Web 2. So just from a familiarity things, it's easier, and it was easier from the account model to build to be programmable. And what we wanted to do is, again, best of both worlds. How do we keep all the benefit of the UTXO model when it comes from how more easily it is to scale, but also how much more secure it is for assets, but still bring this. So we have our own accounting model actually that is called Stateful UTXO, which is basically the best of both worlds. For asset transaction, we leverage the UTXO model, but smart contracts have state, and our virtual machine is Turing complete. And those are a lot of technical terms just to basically say, your smart contract, you can build anything that you want. So you don't have a restriction on what you can build. Anything that you can build on an EVM, you can build on Alephium, but you retain the security for transaction and asset of the UTXO model. And because we have our own accounting model, we also have our own VM, which was anyway something we would not have used EVM because, again, I think Ethereum did. Again, they brought it, they invented it, right? They brought smart contract to the space, and so, but still felt like there was a lot of things that could be improved. And coming after, we wanted to do this, improve on the virtual machine, improve on the developer experience, and develop an environment that was intuitive, where it's difficult to make mistakes, where a lot of the security is built into the VM. You have like security checks, and that, it felt, if you come after something as big as EVM, the least you can, and you can see the pitfalls and some things, don't be lazy, right? Continue to improve on it. And so that's kind of and the founder and the early team is very technical. And so for them, I think they were very frustrated with EVM, and they were like, no way. We want something better for developer and users.
Yeah, and I see here why actually, instead of going into the smart contract side, why you tried to highlight the stateful UTXO, because I think now we can transition more into smart contract side. Because I see obviously UTXO model, like Caspa has UTXO with proof of work, we have UTXO, right? But one thing we don't have is the statefulness on the UTXO side. So I think it's quite interesting to understand. And so now I think if we move forward, so you build this. I mean, I'll probably have to spend time learning through this stateful UTXO, how it works, because it seems interesting. So you had to build it because you wanted to bring smart contract, had to be done because of UTXO model. So then obviously the next step is to build smart contracts through Ralph? Is that how
You
progression happened?
Exactly. So first, of course, you have the accounting model that was different, and then we needed a custom VM, or we would have needed to adapt EVM. But again, we've touched on why we didn't want to do that. And then same thing for the smart contract language, we could have used an existing one, or whether it was an existing bigger language that is used in other thing, or for example using Solidity. But it's kind of the same principle. We wanted to go. I think simplicity is a big trend in what we try and do, is keep things simple and build them up with use cases. And so we didn't want to take, for example, a big language or Solidity, which is extremely, it's a lot harder than people may think, seeing how much it is used. And they wanted a language that was very straightforward, where you don't have 10 different ways to build the same thing, where you really reduce the potential for error. And so, but you also want a language that is easy to pick up. So, or a half or smart contract language is very close to Rust. There's a lot of inspiration to Rust when it comes to the that's another word I can't say in English. Syntax. Sorry, but the way you write it. Is very close to Rust. And honestly, you know, a lot of people ask us always, is like, wouldn't it be easier to just, you know, do EVM and do Solidity? It would, but then it takes away a big value proposition from Alephium, like a really big one. And it's not just a value proposition for Alephium, it's also a value proposition to the entire space. Today we have one technology that is there is one that is the most adopted, and that's it. There's a monopoly a little bit, and the industry needs more mature solutions that have different trade-offs. We've never had someone try it and be like, oh my God, it's too complicated. The actual opposite. We've had hackathon with people. We had one day hackathons. So very short time with people who had never touched Alephium before. And some of them were junior, some of them were less junior, and everyone could pick it up. And, you know, we asked at the end, and everyone said it was very intuitive. It's actually easier than programming on Solana, much easier than Solidity. So in practice, it has never been a blocker from the dev side of things. Because anyway, developers are used to working with several language, no matter, like that's part of what happens when you're a developer. Where it's more challenging, I would say, is more for services. So like if you want to add services to your chain, a lot of services will pretty much only integrate EVM chain, because the integration effort is just very, very low. It's not exactly copy paste, but pretty close to it. So this is the part where not being EVM is more challenging, is because, you know, you have to do a little bit more work to get services to integrate your chain. But but for us, it's worth it, because I think security and usability are extremely important. And if EVM and Solidity in their current state were enough to build an experience that brought the masses to our space, it would have happened. And like, education cannot be the only solution to the complexity of that. There's still improvement that can be made, and so that's what we're proposing.
That's cool. So just moving on to your latest upgrade, Danubu, is that how you pronounce it?
It's again a thing where I think it depends from where you are. I call it Danube because that's how it is called in French. That's how we call the river in French. So for me, I call it Danube, but I think Danube is probably also right. I don't know.
I don't know either. But yeah, I think the numbers really stood out to me for a proof of work chain. This is all achievable, I believe, by the sharding.
Perfect. So sharding. So the concept of sharding, this is a concept that exists in Web2. This is a pretty common way to scale database or anything really. And all it means is that you're partitioning whatever you're trying to scale. So in our case, it means we're partitioning transaction. And I want to go back to what I was saying before between the difference between a UTXO chain and an account-based chain. So again, because Alephium is a UTXO chain, when we split the network, when we partition the network in multiple chain, we're effectively partitioning transaction. So we are assigning transaction to specific blockchain depending on a certain parameters. And I will go back on that. But when an account-based chain does sharding, what they do is they are partitioning accounts and balances on multiple chain. So when they do this, it means that they have cases where they have to deal with cross-chain transaction. Because if you do a transaction between two accounts that are on the same chain, perfect. Like that's what you're used to. But then when you want to do a transaction between accounts that are on two different chain, this is where usually the experience degrade pretty significantly. It's often two steps, and more importantly, that cross-chain transaction isn't secured by the consensus because it's not a on-chain transaction anymore. Whereas when you do sharding on the UTXO model like we do, all we do is that transactions are assigned to a specific chain. So no matter how and where you transact on the network, you're always on a single chain. It's always a single step transaction, and it's always secured by proof of work. So this is one of the big difference, and this is what is so unique about Alephium and what makes also the way we do sharding being so different from the way people have experienced it in the past, and how they might experience it in the future if Ethereum does go ahead with sharding eventually. And so now let's go back to Alephium. So as I mentioned, what we do when we do sharding is that we assign transaction to a specific chain depending on the parameters. So the way it happens, if we want to dive a little bit more, addresses are assigned a parameter that we call group, that is currently with the current network between 0 to 3. And transactions are assigned to a specific chain depending on the group of the address of origin and the group of the address of destination. So if you're doing a transaction between an address in group 0 and an address in group 1, your transaction will be processed by the blockchain 01. If you do a transaction between the blockchain, between an address that is that has the group 2 and an address that has the group 3, your transaction will be processed by the blockchain 2-3.
When you're saying group, right, you're highlighting the different sharded blockchain as such, right? Different shards. Is that what you mean by group?
No. So we use sharding at 2 levels. So again, sharding means partitioning. So we use it at 2 levels. Addresses are assigned a group. It's just a parameters, but basically address are assigned a parameter that is group that is 0 to 3. Sorry, we have 4 groups, 4 addresses, and it's 0 to 3. And then transactions are partitioned onto 16 chain. And how you decide which transaction goes on which chain is based on the group of the address of origin and the group of the address of destination. And then you have a chain that we process transaction, and the chain are directional in a sense. So you have like the chain that will process transaction from addresses in group 0 to group 0, from group 0 to group 1, group 0 to 2, 0 to 3, but then from 1 to 0, 1, 1, 1, 2. And so you have 16 chain. You have 4 groups. You need 4 times 4 chain to have all of the direction. And now with the current the current uses of the chain, that's all that we need. But in the future, that can be increased to 32 groups, and that will be 1,024 chain, basically.
I see.
1,024
so
chain.
This is right. So this is where your 20,000 throughput transaction per second comes in, right?
Right now, today with the 16 chain, that will be 800 TPS.
Right.
That will be 800 TPS because of the size, with the size of the block. This is a pretty conservative estimate, actually. People usually, when they list the TPS, they will take like the smallest size of transaction and things like that to have the highest number. In our case, if you actually go through the literature, you see that it could be more, but exactly because the devs, the estimate is based on the assumption that most transaction will be smart contract based transaction. Maybe that can take us to the block time, because we felt the low TPS of Bitcoin and Ethereum through our experience in Web3. People have been putting a big emphasis on TPS, which is a very important factor, but it's just the throughput, right? As a user, unless your unless the chain you're using, the network you're using is bloated, you will not feel the TPS. Like, this is a metrics that doesn't impact you up until the point the blockchain is saturated, basically. But if your network is appropriately dimensioned and not saturated, the metric, the parameter, the thing that you feel as a user, the speed, is the block time. It's not the TPS. The TPS is the capacity. It is the capacity, and what you really feel when the blockchain is operating normally and it's not, again, saturated, is the block time. And so Alephium, with the upgrade that will activate in 11 days from the time you and I are talking, it will be 8 seconds. And so this is a pretty impressive performance for a proof of work network, generally speaking, but more importantly for a proof of work network that has to deal with smart contracts.
Yeah. I think I was going to say just a couple of things there. Caspa is a proof of work layer 1 without smart contracts, is doing 10 blocks per second right now. But Caspa doesn't have smart contracts on the layer 1. So I think that's the caveat you put there before, which is a valid one, because it's going to make the chain bloaty.
It's different. It's actually a little bit more complex than that. So Alephium, we have 8-second block time per chain. So if you put it with the 16 chain, it actually means the network itself process 2 blocks per second. In the case of Caspa, I'm not an expert, but basically the way Caspa speed come from is because they use the structure of the chain is a DAG. And so you have the thing with Caspa is they have multiple blocks, being mined in parallel, and they reorganize themselves through a certain period of time. And so it's kind of, it's a moving thing for a longer amount of time. And that makes them a lot faster. But that makes it very complicated, if not impossible, in the current state to have smart contract, because smart contract need to know, they need to know the information, because you have to apply a logic on top of it. And so the way, what gives Caspa its speed, it's also what makes it extremely complicated to build smart contract on top of. And they have right now, they also have the classic UTXO model. So with all the similar limitation that you would have on Bitcoin, with very limited scripting thing, which I think is why one of the reason at least why they went through the route of having the smart contract as layer 2 and having the layer 1 more as the settlement layer, and the computation would be on layer 2.
Yeah, I think you're completely right there. The block DAG and Ghost DAG combined, those things actually make Caspa chain. From my point of view, it's the right choice, because they are deciding that layer 2s can bring smart contracts on the chain, right? So yeah.
And exactly. And I also think it's different trade-off. Caspa was optimized for transaction and peer-to-peer transaction, and Alephium was optimized for smart contract. And I think it's extreme. I'm so happy that to see different chain building different things is like, you want to have different approach. It's like this is what will make our industry mature. And it's what they are doing is amazing, like really. And so I think it's really nice to see chain, evolving proof of work and the UTXO model in many, many different ways. And this is what we need. This is what proof of work needs. People forget that a lot of technical innovation, as an individual that we get exposed to, usually they have development cycle that you don't see publicly, and you only get access to the technology once they reach a certain level of maturity. In the case of blockchain, because of the nature of everything being public, people have been exposed to the technology at a stage of its evolution that is much, much earlier than other technology at time. And so sometimes people underestimate how much more innovation needs to happen and can happen in this space.
Yeah, 100%. Just one pushback on sharding, which is which I wanted to understand, and perhaps not a pushback, but just more clarity needed, right? With sharding, especially the traditional sharding, and that's why one of the reasons Ethereum didn't go through with the sharding, and they are sort of thinking with proto dank sharding that's perhaps in the roadmap somewhere in the future. But with the traditional sharding, when you break down the chain, not the accounts, the chain into 16 different chains, right? Each chain becomes its own ledger, right? And each ledger or the chain has to be maintained by nodes, right? These nodes are actually now split. So if you had 100 nodes between, no?
That's not how it is designed here. So the node tracks all of the chain. You could decide to develop a node that track only one chain, but currently the full node tracks all of the chain, and all of the chain are interconnected. Because the really important part, especially is to avoid double spend. You want to make sure that you're not spending the same funds in two different chains and then not knowing.
Yeah.
And this is where we actually do use DAG data structure. So our chain is not a block DAG like Caspa, but DAG is just a data structure, right? And we use it in our case to avoid double spend, which means that, in short, the block on one chain has dependency to blocks on the other chain of the network.
I'm trying to understand how that works. Yeah, is it 16 different chains and you have different nodes that are going through each chain, or is it like the centralized nodes?
No, it's one single. The node covers the whole network. Node cover the whole network, and the chain are interconnected, and the blocks are interconnected. So if you're a block, let's go a little bit into the details. If I'm a block on chain, I'm a block on chain 02. Okay, I'm the last block on chain 02. I have dependencies. So in my header, I basically reference the last block of all of the chain in my group that start in my group. Right. So I will have a dependency, a connection to the last block on chain 00, on the last block on chain 02, and the last block on chain 03.
Okay.
I will also have a dependency to the last block of chain 11, to the last block of chain 22, and the last block of chain 33. And I don't need to have a dependency to any of the other chain, because by having a dependency in the last block of chain 11, I actually indirectly have a connection to all of the other block, because chain 11, the last block of that chain, will also reference the last block of chain 10, 12, 13. So it means that you can scale, the network can scale if G is the number of group, which is the parameter for the address. You can scale the group G times G, but you only need to care, the dependencies you need to track is only 2G minus 1. Meaning you can, just because it's not proportional. So it's not equal. So you can scale it, and it doesn't mean you have to worry about as much thing because of the way it is designed. So this is why it can be scaled all the way to 32 groups, 1,024 chain, and over 20,000 TPS.
Typically, as I said, the sharding chains have had issues where you have a minor shard with less nodes will be exposed to 51% attack, right? If it's again in that case,
so we don't have this.
That's not the case with you guys.
Yeah, exactly, because of the dependency. Exactly because of the dependency, the cost of attacking one chain is the same cost as attacking the entire network. So you don't have the security budget isn't split. Let me tell you about a downside of our sharding approach, because right now I just made it look super amazing, right? So there was one point of friction that we had, which was that to interact with a smart contract, you still can only interact with a smart contract with an address that is in the same group as the smart contract. So if the smart contract is deployed on the chain that has its origin in one group, you have to interact with it with an address that was in the same group. It wasn't too bad as it was, because the wallets automatically generated an address from the same seed. So same seed, you can generate as many addresses as you want in any group as you want, but you still had to manually move your funds to that address. But now with the upgrade, the Danube upgrade that we briefly mentioned, we're actually introducing a new address type that kind of abstract this away, and from the user experience, that whole very complex sharding infrastructure we talked about with groups will be completely hidden from the end users. Right now, they see it because they can see their address. There's something that's an address group 1, group 2, blah, blah, and they could feel it when they integrated with, when they try to interact with a smart contract, if their address wasn't in the same group. But this will be completely abstracted away with an address type that just, it's basically something that comes on top, and you have one address, and then in the background it will redistribute. And so as a user, you won't see this anymore at all. So this upgrade removes kind of the only pain point for the end users that we had with sharding. So,
but I want to move more into a third sort of interesting area that I found when I was going through the just high level, which was the tokenomics of the project, which was quite unique for me when I went through it. And one of the aspects of tokenomics that stood out to me is how much of the emission is being set aside for the miners itself, right? It's like, at least that's how I thought about it, that it's structured for long-term longevity of the project, right? Where you have 1 billion tokens, out of that 85% is set aside to be, for it to be sent out as a reward mechanism for the miners, right, over the next 80 years. So I want to get into the thinking behind the process of tokenomics.
Okay, so the network upgrade introduces a change, but let me tell you about the tokenomics as they are today, and then I will tell you what the upgrade changes and why we're changing that. So Alephium is a proof of work chain, which means our coin, Alf, is being basically issued by the miners when a valid block is being approved, and they mine the Alf. And out of when Alephium launched, we had a hard cap, which means the maximum amount of Alf that could be mined is still today, again, previous to the upgrade, 1 billion, sorry.
Billion, yeah.
1 billion. And so 86% of that 1 billion is for mining reward and will be mined over the first 82 years, pretty much. It's an estimate because it depends on the hash rate, how it quickly grows. Because the part, okay, before I dive into this, I'll do a small parenthesis, because it's part of the tokenomics. We don't have halving on Alephium. The mining reward is actually calculated dynamically at each block based on the hash rate and the time. And it's mainly after 4 years, it's actually only the hash rate that impacts the reward amount. So it's a dynamic thing. We don't have halving. So that's the first thing. And then so now back to the 86% that is from mining. The part where our tokenomics are a little bit different from what people are used to in proof of work, because in proof of stake it's even different, is that our emission schedule is actually very slow. Most, like Bitcoin, after 16 years now, after 16 years, most of it has been mined. It will take more years for the tiny rest to be, but most of it has been mined. We were mentioning Caspa before. They also have a very rapid emission schedule with now, after almost 4 years, I think at least 90% has been mined. In our case, the emission is actually much more, like right now, if you count, I think the emission is around 2 to 1% per year over those 80 years. And it decreases smoothly. So it's a little bit more in the beginning, but it's actually a pretty somewhat linear decrease over those 80 years. And the emission is actually very, very long. And so that's something that is pretty different, because it means that we're very, very far after 4 years. I think around 80% still hasn't been mined. And in the emission rate is around I think it's around 1 to 2% of that. And so this is something very different. And then for the rest, so we mentioned 86.
So Maud, can I ask what was the thinking behind it? Because there is argument could be made, and especially in blockchain space, a lot of discussions happen around demand and supply, how much tokens are available. So this is the other side, right? I talked about the mining side. Like, of course, this seems very specific to mining and the longevity of the project.
So from the miner side, it means that you have a little bit more, a more predictable revenue, and the decrease is not as steep as you have with halvings, because halvings is like 50, you get half of it is gone. You can predict it because you know the date, but it's a pretty, like, imagine it means every 4 years you have to have lowered your electricity cost by half, or increase, like, for the same amount of power, of computing power, you electricity needs to have reduced by half, otherwise you're not profitable anymore. We just wanted something that was smoother for the miner, more predictable. We are also actually introducing, before I talk about the change, let me quickly tap into just the 14% that we haven't talked about quickly, just not that people think we're glossing over it. So the 14%, it was minted with the Genesis block, and it's allocated to different purposes. Part of it was to get sales, to secure funds for the development of the project. There is part that is allocated to the treasury. So this is more for services, like whenever you have to base things in Alph. And then you had an allocation, still have, that's actually, you have an allocation that is for the ecosystem. So that's everything that is like grants, for example, and for the development of the ecosystem. And so that's kind of the remaining one. The challenges with the tokenomics in the structured that we had now with the hard cap at 1 billion was that two things. One that is problematic as of today is that people, the tokenomics were not very digestible for people who don't take the time to dive in, because they're either used to proof of stake like tokenomics or tokenomics, where the entire supply exists from the get-go, or they're used to proof of work chain with rapid emission. And so in our case, for example, the difference between the amount of ALF that exists today and the amount of ALF that can exist is huge. Again, there's 80% that doesn't exist because it hasn't been mined. And that made, like, it meant in the classic calculation that people do, it just looked very, very weird, because again, those and it kind of deterred sometimes people to look into Alephium, because they looked at this, not knowing that it was proof of work with a long emission schedule, and they just looked at the number being a bit like that. And then you obviously always have a question around the security budget once you don't have block reward. It's like, is the usage of your chain enough? Are the fee enough that miners will continue to mine at the same security level, or will you have a big drop because you'll stop being profitable? So this network upgrade removes the cap, meaning that out of 15th of July, there won't be a cap, and after that deadline, ALF can continue to be mined. So this is a change that doesn't change anything compared to the situation before for the first 82 years, because they will be mined at the same rate. So nothing changes effectively for the first 82 years. The only thing that changes is that it just doesn't stop after. And more importantly, it also changed a little bit the way tokenomics are perceived, because now it makes them more digestible and maybe more standard, more standard to what people are used to. And in the end, this is an approach like Monero also has this unlimited supply, and Ethereum as well. They had it when they were proof of work, and they still have it now. They are proof of stake.
They are more inflationary chains, right? So the amount keeps on going up, right? There's no capped supply.
Yes, but it doesn't mean that it will necessarily be inflationary at that stage, because we have a number of deflationary mechanisms. So we have proofoflesswork that I was mentioning before, right? Where 87% actually will now be paid by burning ALF. So it can be that what you burn actually ends up being, offsets what is mined. And more at this stage right now, we are burning 100% of the transaction fee. So we have several deflationary forces. As of today, the deflationary forces don't outweigh the emission, but maybe in the future they could be. So it doesn't mean it will always be inflationary like it is now.
one question on halving. Why, you guys chose not to have any halving?
I'm not the dev, right? So I don't
Right.
know exactly what if I don't know if there was anything beyond wanting to have a more predictable and softer decline in revenue for miners and not something super abrupt.
I want to wrap this up. So let me just quickly ask some rapid fire here about the ecosystem itself that's been built on Alephium now. So what's actually what are the apps that are actually being built? How many apps are there? And sort of on the ecosystem, anything you can perhaps share with us from dApp size to the user numbers that are number of users that are using these dApps.
Yeah. So I think I haven't checked recently, but I haven't checked in 1 month, but last month we had around 320,000 active addresses in the network. In terms of project, we have over 70,000, 70 project into the ecosystem. And this is a pretty broad things, everything that you would expect. DEX, NFT marketplace, prediction market actually are about to launch on mainnet. They are on testnet. We have different model of DEX, whether it is IMM, CLAM, V33. So we have different models.
Yep.
We are starting to see lending. We had the first over collateralized stablecoin with the lending protocol launched earlier this year that is getting a lot of traction. We have more lending protocol that are coming in, like Morpho style as well. One big success is that we got a pretty big RWA tokenization use cases that has been announced, but because it is a RWA actually on the energy side of things, this is project that take years versus days or months.
Yeah.
Because this is infrastructure, right? That needs to be deployed. That is a very cool validation. We also have made a big effort around again services that are available, oracles, hardware wallets, software wallets. So we have Alephium is supported in pretty much the leading hardware wallet, Ledger, Tangem, which I also say with a French accent, so nobody knows which one I'm talking about, but it's the one with the ring. SafePal,
Right.
OneKey, and
Right.
many others. There's really a lot of cool things. We're having like right now as part in our grant program, we're having a lot of like yield generating dApp, like DeFi protocol that are in going through the grant program. And I'm really happy because the more complex use cases and projects you have, the longer it takes for them to go to market at the end of the day, because building is a little bit more complex. But I'm very happy because we have more and more grant applicants, basically, with more and more ambitious projects. So pretty excited to see all of those coming to fruition.
Awesome.
Anyway, coming on chain. We had the first over collateralized stablecoin with the lending protocol launched earlier this year. That we got a pretty big RWA tokenization use cases that has been announced, but because it is a RWA actually on the energy side of things, this is proof of work remained today the most robust and decentralized consensus algorithm that also is accessible